September 23, 1940. Camp Holabird, Maryland. A small, boxy vehicle rolled through the gates of the Army's Motor Transport Testing Facility, still warm from a 170-mile drive through Pennsylvania hills. Painted olive drab, weighing barely 1,850 pounds, it looked more like a motorized wheelbarrow than a military vehicle. The two men who had driven it from Butler, Pennsylvania, Karl Probst and Harold Christ, had pushed the little machine to its limits just to arrive on time. They'd started the journey cautiously, braking in the engine. But as the clock ticked toward the Army's 5 p.m. deadline, caution gave way to desperation. They arrived with 30 minutes to spare. Major Herbert Lowes, the camp's purchasing officer, walked around the vehicle slowly. He'd seen every military vehicle the Army had purchased for 20 years. Nothing looked like this. It had no doors, no real body, just a flat hood, exposed seats, and 4 wheels that seemed too large for the frame. Probst and Christ watched nervously as Lowes climbed in, started the engine, and drove toward the test track. What happened next would change warfare forever. But this story doesn't begin with a vehicle. It begins with desperation.
July 11, 1940. Europe was burning. France had fallen 21 days earlier. Britain stood alone against Nazi Germany. The Blitz was about to begin. And the United States Army had a problem that terrified its leadership. America was catastrophically unprepared for modern mechanized warfare. The U.S. military still relied heavily on motorcycles with sidecars and aging Ford Model Ts for light reconnaissance. Meanwhile, German panzer divisions were racing across Europe in standardized, purpose-built military vehicles that had been in development since 1933. The Wehrmacht's Einheits PKW program had already produced tens of thousands of standardized military vehicles. Germany was even deploying a second generation, the nimble Volkswagen Kübelwagen, designed specifically as a cheap, light, multi-purpose off-roader. America was 7 years behind. The U.S. Army Quartermaster Corps sent bid invitations to 135 automotive manufacturers. The specifications seemed designed to guarantee failure. The vehicle must weigh no more than 1,300 pounds, later revised to 2,160 pounds, have 4-wheel drive, carry a crew of 3, mount a .30 caliber machine gun, feature a wheelbase no longer than 75 inches, later 80 inches, produce 85 foot-pounds of torque, climb a 30-degree grade, carry a 660-pound payload, ford water crossings at least 18 inches deep, and have a fold-down windshield. The timeline was more impossible than the specifications. 11 days to submit a bid, 49 days to deliver a working prototype, 75 days to produce 70 test vehicles, 130 days total, start to finish. The big automakers, General Motors, Chrysler, Packard, looked at the requirements and laughed. Impossible! The deadline alone made it absurd. Design and build a completely new vehicle type in 7 weeks? Preposterous! 133 companies declined to even respond. 2 companies answered the call. Both were small. Both were flirting with bankruptcy. Both were building 4-cylinder cars when the rest of America had moved to 6- and 8-cylinder engines. American Bantam Car Company in Butler, Pennsylvania, and Willys-Overland Motors in Toledo, Ohio, were the only manufacturers desperate enough or visionary enough to try.
American Bantam had a problem beyond the obvious ones. The company had no engineers on staff who could design a military reconnaissance vehicle. They had nobody to draft the plans. They were a tiny company building tiny cars, and they were months away from bankruptcy. Harold Christ,
Bantam's plant manager, made a desperate call to Karl Probst in Detroit. Probst was a talented freelance designer who had worked for several automotive companies. He initially turned Bantam down. The project was impossible. Then the Army contacted Probst directly. Something in that conversation changed his mind. On July 17, 1940, Probst began working without salary, without a contract, with nothing but a desperate belief that he could solve the unsolvable. He drafted complete plans in 2 days. Not sketches, not concepts, complete technical drawings for an entirely new type of vehicle, using off-the-shelf automotive parts where possible and custom four-wheel drivetrain components from Spicer. He calculated costs the next day. On July 22nd, Bantam submitted their bid, complete with detailed blueprints, exactly on deadline. Then, the real work began. The vehicle Probst designed had to be hand-built in Bantam's workshop in Butler, Pennsylvania. Every part had to work perfectly the first time. There would be no time for redesign, no opportunity to fix fundamental errors. The Army's deadline was absolute, 49 days. Miss it by 1 hour, and the contract would go to whoever could deliver. Probst and Christ worked around the clock. The Bantam team assembled the prototype, watching nervously as each component came together. Engine, transmission, four-wheel drive system, suspension, body panels. Everything had to fit. Everything had to work. On September 21st, the prototype fired up for the first time. They dubbed it the Blitz Buggy, a reference to the Nazi Luftwaffe's aerial assault on Britain that was happening at that very moment. They had 2 days to drive it 170 miles to Camp Holabird. The journey became the vehicle's first real test. Probst and Christ drove slowly at first, braking in the engine, listening for problems. But as the deadline approached, they pushed harder. Up Pennsylvania hills, through rough terrain, the little vehicle responded. It kept going. By the time they rolled through Camp Holabard's gates on September 23rd, they knew they had built something special. Major Laus took the Blitz Buggy onto the test track. What happened next entered military legend.
Camp Holabird near Baltimore, Maryland, wasn't just a testing facility. It was an automotive hell designed to destroy vehicles and expose every possible weakness. Established in 1917 as a motor transport training center, by 1940 it occupied more than 160 acres and housed nearly 7,000 personnel. It was responsible for $14 million worth of transport equipment. The test facilities had been built specifically to simulate the worst conditions military vehicles would face in combat. Muddy swamps that could bog down anything without sufficient ground clearance or traction. Water crossings of varying depths to test waterproofing and fordability. High-speed sections on paved roads to evaluate reliability at sustained speeds. Side slope courses tilted at terrifying angles to test rollover resistance. And the most famous feature, Tank Hill. Tank Hill featured 3 concrete ramps, each attacking the hill at a progressively steeper incline. The final ramp climbed at 65 degrees, an angle so severe that walking up it was a challenge. The previous generation of military vehicles couldn't climb it. Hell, most vehicles couldn't even approach it without sliding sideways. Major Laus drove the Bantam Blitz Buggy straight at Tank Hill's steepest ramp. The little vehicle attacked the incline without hesitation. Four-wheel drive engaged. Gears held. The engine, despite producing only 45 horsepower, pulled the lightweight frame up the 65-degree slope. At the top, Laus turned the vehicle around and drove straight back down. Forward, backward, side approaches. The Bantam conquered Tank Hill repeatedly. Then came the mud swamps, the water crossings, the high-speed runs. For 30 days, Army test drivers subjected the Bantam prototype to conditions that would have destroyed most civilian vehicles in hours. They drove it 3,700 miles in total. They pushed it, beat it, tried to break it. The Bantam kept running. Lieutenant E.P. Hogan of the Quartermaster Corps later wrote, "I have driven every unit the services have purchased for the last 20 years. This is the most remarkable vehicle I've ever tested." But the Army had a problem. A good problem, but a problem nonetheless. American Bantam could build excellent prototypes, but they couldn't build 75 Jeeps per day, which is what the Army calculated they would need. Bantam didn't have the production capacity. They didn't have the manufacturing infrastructure. They didn't have the financial resources. So, the Army did something that would become controversial for decades. They shared Bantam's detailed technical drawings with two other companies. Willys-Overland and Ford Motor Company were invited to build their own prototypes based on Bantam's design. The Army claimed they owned the blueprints because they'd been created for a government proposal. Bantam was in no position to object. They needed the work too desperately. The race was about to get more complicated.
November 13, 1940, Willys-Overland delivered their prototype to Camp Holabird exactly 75 days after beginning design work. They called it the Quad, a reference to its four-wheel drive system, echoing the four-wheel drive trucks Nash had supplied to the military during World War I. 10 days later, on November 23rd, Ford delivered their prototype, the Pygmy. All three vehicles looked remarkably similar. This was hardly surprising. Willys and Ford had both seen the Bantam prototype in action and had access to Bantam's detailed technical drawings. But each company had made subtle changes based on their own engineering philosophy. Bantam's BRC-60 was the lightest at 1,850 pounds and the most fuel-efficient. It had 9 slots in its grille and featured the original design elements Probst had created. It was nimble, quick, and performed beautifully on the test track. Willys' Quad was heavier at 2,450 pounds, well over the Army's weight specification. But it had something the others didn't: raw power. Delmar, or Barney Roos, Willys' chief engineer, had developed a remarkable 4-cylinder engine called the Go Devil. Displacing 134 cubic inches, this L-head inline-4 produced 60 honest horsepower at 4,000 RPM and 105 foot-pounds of torque. In a vehicle weighing just over a ton, that power was transformative. The Willys could accelerate faster, climb steeper grades, and pull heavier loads than its competitors. Ford's Pygmy featured superior build quality and engineering details Ford had perfected through decades of mass production experience. Most notably, Ford engineers had designed a flat, stamped steel grille with 7 slots, lighter than Bantam's welded 9-slot design, and far better suited to mass production. Ford's prototype also featured an inverted U-shaped front crossmember that was stronger and easier to manufacture than the alternatives. The Army tested all 3 prototypes through November and December 1940. The tests were brutal. Each vehicle was driven thousands of miles over every type of terrain Camp Holabird offered. Engineers measured acceleration, braking distance, fuel consumption, maximum speed, climbing ability, and durability. A. Wade Wells later wrote in his 1946 book, Hail to the Jeep, quoting Willys' test driver Donald Knauer about the cross-country testing. The next part of the test was what they called cross-country. They took us out to the roughest terrain they could find: gullies, mud holes, steep hills, loose sand, water crossings. They wanted to see if we could go anywhere. And we could. By late 1940, the Army was desperate. The war in Europe was accelerating. Britain needed help. The Soviet Union would soon be fighting for survival. America needed these vehicles immediately. In November 1940, the Army awarded contracts to all 3 manufacturers for 1,500 vehicles each. The competition would continue into production. Each company would build 1,500 pre-production units for further field testing. The original weight specification was officially abandoned. The Army acknowledged that 1,300 pounds or even 2,160 pounds was unrealistic. The new limit, whatever, worked. The vehicles received new designations for their pre-production runs. Bantams became the BRC-40. Willys's was labeled the MA, Military Model A. Ford's was the GP, Government Contract 80-inch wheelbase. Production began in early 1941. From fewer than 100 Jeeps in all of 1940, production skyrocketed to 8,500 vehicles by the end of 1941. But they weren't standardized, they weren't interchangeable. They were still 3 different vehicles competing for final selection. The Army needed to choose. Spring and summer of 1941 saw the most intensive vehicle testing program in American military history. Thousands of pre-production Jeeps from all 3 manufacturers were subjected to field testing at Camp Holabird, Fort Benning in Georgia, and field conditions worldwide. The Army wasn't just testing whether the vehicles worked, they were testing whether soldiers could maintain them under combat conditions, whether parts could be standardized, whether the vehicles could survive extended operations far from supply bases. Every component was pushed to failure, then redesigned. The windshield. Soldiers kept losing the keys to locked windshields, so key ignitions were removed entirely. The windshield position. It needed to fold flat for shipping and to reduce the vehicle's profile in combat, so engineers redesigned the mounting system. The fuel tank. The original 11-gallon tank provided insufficient range, so it was enlarged to 15 gallons. The headlamps. Small lamps didn't provide adequate visibility, so larger 5-inch sealed beam units were adopted. The handbrake. Originally positioned on the driver's left on the Willys MA, it was relocated to the center where passengers could reach it in emergencies. The gear shift moved from the steering column to the floor for standardization with other Army trucks, ensuring drivers could switch between vehicles without confusion. Meanwhile, the competition intensified. The infantry board and combat arms commanders favored Bantam's work. They delivered first and their vehicle performed beautifully, but the Quartermaster Corps and the Defense Commission recognized brutal reality. Bantam couldn't scale production to meet wartime needs. Willys and Ford could. Controversy erupted in November 1941 when several magazines charged that the Army was favoring Ford, the giant corporation, over Bantam, the plucky underdog who had actually invented the vehicle. Calls for congressional inquiry echoed through Washington. But time had run out for debate. The decision had to be made. In July 1941, after extensive comparative testing, the Army's Infantry Board issued their conclusion. The Willys MA was superior in acceleration, maximum speed, grade climbing, and cross-country performance. The Go Devil engine was the difference. That extra power translated into combat capability. The Willys could pull artillery. It could climb hills that stopped the others. It could accelerate out of danger faster. Willys-Overland was awarded the first major production contract, 16,000 vehicles at $738.74 per unit. But the design wasn't finished. The Army demanded that Willys incorporate the best features from all 3 competing vehicles. Ford's stamped steel 7-slot grille replaced the Willys' heavier welded slat grille design. Ford's flat hood design simplified production and reduced weight. Bantam's transmission and differential from Spicer proved superior to Willys' original choices. Willys' Go Devil engine remained the heart of the vehicle. The final design, designated the Willys MB, Military Model B, represented the collaborative work of 3 manufacturers and dozens of Army engineers. Lieutenant E.P. Hogan wrote in fall 1941, "Credit for the original design of the Army's truck, quarter-ton, 4x4, may not be claimed by any single individual or manufacturer. This vehicle is the result of much research and many tests." It was a vehicle designed by committee, which almost never works in automotive history. Except, this time, it worked perfectly. But there was still one critical problem. Even Willys couldn't build vehicles fast enough. December 7, 1941, Pearl Harbor.
Everything changed in one morning. America was at war. The military's projected need for reconnaissance vehicles exploded overnight. 16,000 jeeps? That number was laughable. The Army would need hundreds of thousands. Within weeks, Ford Motor Company received an unprecedented contract. Build jeeps to Willys specifications. Build them with interchangeable parts. Build them as fast as humanly possible. Ford's vehicle would be designated the GPW. Government contract, 80-inch wheelbase, Willys design. The W was critical. Ford had to manufacture another company's design with another company's engine to another company's specifications. For Ford, accustomed to controlling every aspect of their vehicles, this represented extraordinary cooperation. Well, mostly cooperation. Ford, in characteristic Ford fashion, refused to simply copy Willys without putting their stamp on it. Every single part Ford manufactured, every bolt, nut, bracket, and panel was stamped with a small F. Thousands of Ford parts, each marked to ensure the world knew Ford's contribution. Willys engineers weren't amused, but they couldn't argue with Ford's production capability. By November 1941, Willys-Overland began mass production of the MB at their Toledo, Ohio plant. By February 1942, Ford began production of the GPW across multiple facilities. What happened next demonstrated American industrial might like nothing before it. The production numbers tell an extraordinary story. 1940, fewer than 100 Jeeps total, all prototypes. 1941, 8,500 Jeeps, BRC 40, 2,605, Willys MA, 1,555, Ford GP, 4,458. 1942 production standardized to Willys MB and Ford GPW specifications. 1943 to 1945, mass production began. Peak production at Willys-Overland's Toledo plant, 1 Jeep every 80 seconds. Ford's multiple plants combined to produce 1 Jeep every 90 seconds. Think about that. Every minute and a half, a complete vehicle rolled off an assembly line. Fully functional, battle-ready, capable of crossing deserts, fording rivers, climbing mountains, and carrying wounded soldiers to safety. From November 18, 1941, to September 21, 1945, Willys-Overland 361,339 MB units produced. Ford Motor Company 277,896 GPW units produced. American Bantam 2,675 earlier models. Total production 647,925 Jeeps in 4 years. 1/4 of all non-combat motor vehicles produced by the United States during World War II were Jeeps. Nearly 2/3 of all light 4x4 vehicles produced during the war were Jeeps. The standardization proved brilliant. A Willys MB and Ford GPW were mechanically identical. A part from one would fit the other. This meant repair in the field was simple. Cannibalize parts from disabled vehicles to keep others running. No need to track which manufacturer built which Jeep. They were interchangeable. Well, almost entirely interchangeable. Ford's inverted U-front crossmember differed from Willys' tubular design. Ford's F-stamps covered everything. But the critical components, engine, transmission, differential, wheels, body panels, were identical. The American Bantam Car Company, which had invented the vehicle and delivered the first working prototype, built fewer than 3,000 Jeeps total. In 1942, Bantam was reassigned to build quarter-ton trailers for Jeeps as well as torpedo motors. They proved highly capable in these roles, but they would never build another complete Jeep. In 2015, the Pennsylvania General Assembly unanimously adopted House Resolution 382, explicitly resolving that Bantam of Butler, Pennsylvania, invented the Jeep, calling it one of the most famous vehicles in the world. The resolution acknowledged that Bantam were the only party to deliver a working prototype of a light four-wheel drive reconnaissance car within the required 7 weeks, which withstood 30 days of Army testing at Camp Holabird. History is written by the survivors. Bantam invented the Jeep. Willys perfected it.
Ford mass-produced it. But Willys owned the trademark, and Willys' name became synonymous with the vehicle. The testing, refinement, and production represented one of the most remarkable engineering achievements in history. From impossible deadline to standardized mass production in less than 2 years. But testing wasn't over. Now the real testing would begin on battlefields across the world.
No testing facility could replicate actual combat. Camp Holabird's steep hills and mud swamps were brutal, but they weren't being shelled by enemy artillery. The torture tracks didn't include machine gun fire, mine explosions, or desperate soldiers pushing vehicles far beyond their design specifications. Combat would reveal whether the Jeep was actually ready. North Africa. Jeeps landed with American forces in Operation Torch in November 1942. They crossed the Sahara Desert, operating in temperatures exceeding 120 degrees Fahrenheit. Sand infiltrated everything. Engines, transmissions, differentials. The Jeeps kept running. Field mechanics learned to clean air filters multiple times daily. They learned that overheating was rarely a problem, despite the desert heat. The Go Devil engine was overbuilt and remarkably tolerant of abuse. Italy. Jeeps towed 37mm anti-tank guns up mountain roads the Germans thought impassable. They forded rivers, crossed rubble-strewn streets and destroyed cities, and carried wounded soldiers down from mountain fighting positions. The low gearing meant Jeeps could climb grades that stopped larger vehicles. Normandy. On June 6, 1944, hundreds of Jeeps were loaded into Horsa gliders and landing craft. They rolled off onto Normandy beaches under heavy fire. Many Jeeps were hit. Bullets punched through thin body panels, shrapnel shredded tires. But the vehicles were so simple mechanically that field repairs could get them running again within hours. Soldiers cannibalized parts from destroyed Jeeps to keep others mobile. Pacific Islands. Jeeps landed in the first waves at Guadalcanal, Iwo Jima, Okinawa, and dozens of other islands. They crossed volcanic ash, mud, coral rock, and jungle. The humidity rotted canvas tops and corroded metal. Salt air from the ocean accelerated rust. Jeeps weathered it all. One Jeep, nicknamed Old Faithful, was awarded a Purple Heart after being hit by Japanese naval gunfire at Guadalcanal. It received 2 shrapnel holes in its windshield, but kept running. Old Faithful served 18 months in combat, traveling more than 11,000 miles through jungle terrain as a command car for 4 different Marine generals before being retired and sent on war bond tours. Eastern Front. Under the Lend-Lease program, approximately 182,597 Jeeps, 30% of total production, were shipped to Allied nations. The Soviet Union received tens of thousands. Soviet soldiers loved them. The Jeep's simplicity meant even poorly trained mechanics could maintain them. Most importantly, they were reliable in ways Soviet vehicles often weren't. Soviet generals preferred riding in Jeeps to Soviet-built staff cars. The combat testing revealed patterns. Mechanical failures were rare. When Jeeps broke down, it was usually due to obvious causes: running out of oil, catastrophic battle damage, or extreme abuse. The Go Devil engine was nearly bulletproof mechanically. Fuel efficiency was excellent for a 4x4 vehicle. Jeeps averaged 15 to 20 miles per gallon, far better than heavier trucks or armor. The vehicles were almost infinitely adaptable. Soldiers mounted .30s and .50 caliber machine guns on Jeeps. They added armor plating, though this usually made the vehicle dangerously heavy. They removed windshields for better visibility. They added stretchers to convert Jeeps into ambulances. They welded on brackets for radios, extra fuel cans, ammunition boxes, and supplies. Perhaps most importantly, the Jeep became a psychological weapon. German soldiers came to believe that every American soldier had his own Jeep. When German forces heard Jeeps approaching, they knew American infantry wasn't far behind. Some German soldiers, it was later reported, thought Jeeps were tracked vehicles because they saw them go places tracked vehicles could barely reach. General George C. Marshall, U.S. Army Chief of Staff during World War II, would later call the Jeep America's greatest contribution to modern warfare.
President Dwight D. Eisenhower, who had commanded Allied forces in Europe, called it one of 3 decisive weapons the U.S. had during World War II, alongside the atomic bomb and the Douglas C-47 transport aircraft. Ernie Pyle, the legendary war correspondent, wrote shortly before being killed in 1945, "Good Lord, I don't think we could continue the war without the Jeep. It does everything. It goes everywhere. It's as faithful as a dog, as strong as a mule, and as agile as a goat." The New York Museum of Modern Art included a military Jeep in its permanent collection, displaying it alongside 8 automobiles and calling it one of the very few genuine expressions of machine art. The vehicle that had been designed in 49 days, tested to destruction for months at Camp Holabird, and mass-produced at impossible speeds, had proven itself in the ultimate test: actual war against a capable, determined enemy.
The war ended in 1945. Suddenly, America had hundreds of thousands of Jeeps and no war to use them in. Surplus military Jeeps flooded the market. Veterans were offered first choice to purchase them for pennies on the dollar, often $50 to $150 for a vehicle that had cost the government $738.74 to manufacture. Soldiers who had driven Jeeps through Europe, Africa, and the Pacific Islands bought them to use as farm vehicles, hunting trucks, and general transportation. They already knew that Jeeps could go anywhere and survive anything. But Willys-Overland saw something more: a market. Even before the war ended, Willys began advertising a Jeep in civvies for civilian use. In 1942 and 1943, anti-war campaigns promoted the Jeep's strength and dependability as critical for post-war reconstruction. Farmers needed tractors. Construction crews needed rugged transportation. Rural America needed vehicles that could handle primitive roads. In 1945, Willys introduced the CJ-2A, Civilian Jeep 2A, essentially a demilitarized MB with some creature comforts added: a tailgate, larger headlights, side-mounted spare tire, external fuel cap, and Willys embossed on the hood sides. MSRP $1,090. The CJ-2A was marketed as the all-around farm workhorse. Advertising claimed it could do the work of 2 heavy draft horses operating at 4 miles per hour for 10 hours a day without overheating. The marketing slogan: "A powerhouse on wheels." Willys developed power takeoff units and belt-driven governors that let the Jeep operate farm implements and industrial tools. The little vehicle could plow fields, pump water, cut timber, generate electricity, and transport loads. The CJ-2A became a massive success. Farmers loved it. Construction companies bought fleets. Rural communities used them for everything from firefighting to ambulance service. On February 13, 1943, Willys-Overland had filed a trademark application for the name Jeep. The trademark was granted in 1950, officially making Willys the owner of the name that had organically emerged during testing. The CJ series continued for decades. CJ-3A, 1949 to 1953, 132,000 produced. CJ-5, 1954 to 1983, over 600,000 produced. CJ-7, 1976 to 1986, over 379,000 produced, and CJ-8 Scrambler, 1981 to 1985, over 27,000 produced. Each generation maintained the essential character of the original Willys MB: simple, rugged, go-anywhere capability. The basic design: separate body and frame, high and low ratio four-wheel drive, rigid live axles with leaf springs, high fenders, fold-flat windshield, and modular construction remained fundamentally unchanged for 40 years. In 1987, Chrysler acquired the Jeep brand. The CJ was replaced by the Wrangler, which continued the lineage. Today's Jeep Wrangler still features the 7-slot grille Ford designed in 1941. The basic proportions echo the original MB, and Wrangler owners know their vehicles can trace their lineage directly back to that little Bantam prototype that Karl Probst designed in 2 days in July 1940. So how much testing did the Jeep actually endure before mass production? The testing wasn't measured in total hours across all prototypes. though if you calculated every hour of every test vehicle from September 1940 through July 1941, you'd exceed 50,000 hours easily. Here's what the actual testing entailed. Bantam prototype, September-October 1940, 30 days of continuous Army testing at Camp Holabird, 3,700 miles driven on test courses, every conceivable terrain condition replicated, multiple drivers pushing the vehicle to destruction, survived completely intact. Willys and Ford prototypes, November-December 1940, similar 30-day intensive testing cycles, comparative evaluation against the Bantam prototype, thousands of additional miles per vehicle, multiple prototypes built and destroyed to find weaknesses. Pre-production testing, January-July 1941, 1,500 vehicles per manufacturer built for field testing, 4,500 total vehicles tested under real-world conditions, distribution to military units worldwide for evaluation, combat simulations at Fort Benning and other bases, cross-country runs measuring fuel economy, durability, and logistics, each vehicle driven hundreds or thousands of miles. Redesign and refinement, spring-summer 1941, dozens of modifications tested and retested, component failures analyzed and redesigned, standardization testing to ensure interchangeability, each modification verified through additional testing cycles. Final standardization, July-November 1941. MB and GPW specifications finalized. Production samples tested to confirm manufacturing quality. Additional field testing of production vehicles. If you calculate conservatively, estimating that the Army tested 100 different vehicles for an average of 500 hours each during the critical development period, that's 50,000 hours right there. The actual number was almost certainly higher. But the testing never really stopped. Every vehicle that rolled off the assembly line was tested before shipment. Quality control inspectors drove each Jeep to verify it met specifications. And of course, the ultimate testing happened in combat, where tens of thousands of Jeeps were subjected to conditions no test track could replicate. The depth of testing is why the Jeeps succeeded where previous military vehicles had failed. The Army and the three manufacturers didn't just build a vehicle, they built a vehicle system, tested to destruction, refined based on real failures, and standardized for mass production and field repair. What does the Jeep story teach about engineering, testing, and military procurement? Lesson 1. Impossible deadlines force innovation. The Army's 49-day deadline seemed absurd. It was absurd. But that absurdity forced Karl Probst to design a vehicle using off-the-shelf components and proven technology. He couldn't develop anything new. There wasn't time. So he assembled existing parts in a new configuration. That constraint produced brilliance. Lesson 2. Testing to failure reveals truth. Camp Holabird's torture tracks didn't just test whether vehicles worked. They tested until vehicles broke, revealing exactly where weaknesses existed. Every failure led to a redesign. Every redesign was tested again. The process was brutal, expensive, and absolutely necessary. Lesson 3. Collaboration beats competition in wartime. The Army's decision to share Bantam's blueprints with Willys and Ford was controversial. Bantam had earned the right to exclusive production through their 49-day miracle. But the Army recognized that winning the war mattered more than rewarding the first company to deliver. The final Jeep combined the best elements of all three manufacturers' designs. That collaboration produced a better vehicle than any single company could have built. Lesson 4. Standardization enables scale. By July 1941, the Army insisted on complete standardization. Every MB and GPW had to use identical specifications and interchangeable parts.
That standardization meant field repairs were simple. Any part from any Jeep would fit any other Jeep. It meant spare parts logistics were manageable. It meant soldiers could switch between vehicles without retraining. Lesson 6. Sometimes committees get it right.
The Jeep proved the exception. Multiple manufacturers, dozens of Army engineers, and countless soldiers contributed ideas. The result was a vehicle that excelled in versatility, durability, and performance, becoming an indispensable asset in warfare and beyond. This collaborative process demonstrated that under the pressure of necessity and with clear objectives, diverse inputs can yield superior outcomes. Lesson 7. Adaptability ensures longevity. The Jeep's design emphasized modularity and ease of modification, allowing it to evolve from a reconnaissance vehicle into ambulances, command cars, weapon platforms, and even makeshift tractors. This inherent flexibility extended its utility far beyond the battlefield, facilitating its transition to civilian applications and ensuring its relevance for generations. In engineering terms, building with adaptability in mind mitigates obsolescence and maximizes return on investment. Lesson 8. Historical recognition requires perspective. While Willys-Overland and Ford dominated production and branding, the contributions of American Bantam underscored the importance of acknowledging foundational innovations. The Jeep story illustrates how procurement decisions driven by practical exigencies can overshadow originators. Yet subsequent recognitions, such as Pennsylvania's 2015 resolution, highlight the value of historical accuracy in preserving the full narrative of technological advancements. In retrospect, the Jeep's journey from a desperate prototype to a global icon exemplifies the convergence of ingenuity, rigorous testing, and industrial resolve. What began as an improbable response to an urgent military need evolved into a symbol of American engineering prowess. The exhaustive evaluations at Camp Holabird and in combat zones not only validated the vehicle's design, but also set precedents for modern vehicle development. Today, as contemporary off-road vehicles draw inspiration from its principles, the Jeep remains a testament to the enduring impact of thorough, failure-driven testing in shaping tools that withstand the trials of time and terrain.